students, welcome to today's class. Our today's lesson is exercise 1.2 creative questions. First of all, we will do question number 10. At first, read the question from your book. A farmer buys 595 plants for making a garden. The price of each plant is taka 12. Question number A says, how much money did he spend to buy the plants? So it's very easy. We have to just find the price of the plants. So we have to multiply 12 by 595 to find the total price of the plants. Question number A. He spent in total 595 times 12 taka. Therefore, if we multiply, you can rough, we will get the answer as 7,140 taka, which completes question number A. Now, question number B. How much money of the plants will be left if number of plants in each row of the garden is equal to number of rows? That means number of plants will be equal to the number of rows of the garden. That means we have to check if 595 is a perfect square or not. If 595 is not a perfect number square, then how many plants left after arranging them in a square shape? So at first, we can write 595 we need to find whether 595 is a perfect square number. Therefore, 595, if we check, 2 times 2 is 4, and 2 times 2 is 4, double, and then we check just like 4 and 4, and we'll get 176. Now if we subtract, we'll get 19. So 19 is the remainder here. Now this 19 plants will be left if we want to arrange this 595 plants where the number of plants and number of rows of the garden will be equal. So we can write here 19 plants will be left. From the question, you can write the language. 19 plants will be left if number of plants in each row is equal, each row of the garden is equal to number of rows. Which completes question number B. Now we move on to question number C. First, we read the question. What is the least number which is to be added to the difference of the number of spending of total taka and the number of plants so that the sum will be a perfect square number. That means You read the question carefully. What is the least number which is to be added? When this type of problem, what is the least number which is to be added, which will be a perfect square number, then we again have to check the given number is a perfect square or not. Before that, we have to find the difference of the number of spending of total money of the plants and the number of the plants. So the difference, at first we need to find the difference. So the difference is equal to the total money, 7,140 and 595. So the difference will be 6,545. Now we have to check if 545 is a perfect square number or not. Now 6,545, if 8 times 8 is 64, and now after subtracting and put down 45, if we make it double here, 16, here will be 0 times 0 will be 0. So the remainder is 145. Clearly 6,545 is not a perfect square. So we have to find the nearest perfect square of this number. Now here the next perfect square number will be 80 plus 1 whole square, that is 81 square. Therefore, we need to add 81 square minus 6,545. So we have to add this number so that the number will be a perfect square. Now we find this answer. 81 square means 6,561. Now if we minus 6,545, we will get 16. So our required number, our required least number is 16. Therefore, required least number is equal to 16, which completes our answer. Alright, I hope you understand it very well. Now we move on to our next creative question, question number 23 from your textbook. Question number 23 asks, $384 and 2,187 are two numbers. Question number A asks, verify with factors whether the first number be perfect square number. That means question number A, the first number is 384. The first number is equal to 384. Now we have to check that it is a perfect square number or not. Now if we divide it by 2, we will get 192. Again, if we divide it by 2, we will get 96. Then we get 48. Then we get 24. And then we get 12. and then we get 6, and finally we get 3. And therefore 384 will be 2 times 2, this is a pair, 2 times 2, this will be another pair. So we take 1, 2, 3, 4. Now 2 times 2, another pair, and finally we got this 2 times 3. Now here the first 3 pairs are in pair of similar number, but the last 2 numbers are not in pair with the same number. So this number is not a perfect square. Therefore 384 is not a perfect square. Which completes our question number A. Now we move on to next question, question number B. If the second number is not perfect square number, what is the least number to be multiplied to get a perfect square number? What is the perfect square number? Now, the second number is 2187. So this is not a perfect square number, and the question asks what least number to be multiplied. When it is asked in the question a number is multiplied or divided, we have to make it check this is a perfect square number or not by doing Euclid method as number A. So 2187, clearly it will not be divisible by 2. So we check it with 3 and we will get 729. Again with 3 we will get 243. Again we check and we will get 81. Again divided by 3 we'll get 27, and finally we'll get 3. So all are the 3. Now if we write this as the pairs of numbers, we'll get 3 times 3 as a pair, first 2, and then again we get 3 times 3 another pair, again we get 3 times 3 another pair, but the last one is not in pair. So if we want to make 2187 as perfect square number, we have to multiply it by 3. Therefore the least number is 3, which is to be multiplied with 2187 to make it perfect square. Perfect square. Now question number asks again, what is the perfect square number? That means we need to know, therefore the perfect square is 2187 times 3. So if we multiply it by 3, we will get 6561, which is the perfect square number, which completes our question number B. Now we move on to our next question, question number C. Question number C asks, what is the best number to be added with the second number so that it will be a perfect square number? That means now we have to check whether 2187 is a perfect square number or not by squaring, by finding the square root. So if we make pair, there will be 2 pairs. At first we take 4 times 4 will be 16. Now if we make it double here, at first we have to subtract and put down the next pair. Now if we make double of 4, it will be 8. And now if we check here 6 and 6 here. So we'll get 6 times 6, 36, in hand 3, 6 times 8, that will be 51. 516. Now, if we subtract, we'll get 71. Now, clearly, this is not a perfect square number. So, to make it perfect square, we have to add 1. Therefore, the nearest perfect square number is 46 plus 1 whole square, that is 47 whole square. So which will be 2209. Now if we subtract, therefore our required number we will subtract the given number from our result. So we subtract 2187 from our new result 2209. So we'll get 22, which completes our answer. I hope you understand. Now we will move on to our next question. Okay, now we will start question number 24. At first we read the question. Troops can be arranged in 6, 7 and 8 rows, but not in a square form. Question number A asks, find out factors of 8. Question number A, which is very easy, factors of 8. So we write as Euclid method, 2 times 4 is 8 and 2 times 2 is 4. Now if we write this as factor, therefore 8 equals to 8 times 1. It also can be write as 4 times 2. Therefore factors of 8 are 1, 2, 4, 8. These are the factors of 8. In many ways you can write the factors of 8 you can find. Now question number B. What is the least number by which the number in troops is to be multiplied so that the troops can be arranged in a square form? Now, the number of the troops, the number of the member of the troops is the number of soldiers is the LCM of 6, 7 and 8. Therefore LCM of 6, 7 and 8 is LCM is equal to 168, which will be number of troops, which is not a perfect square number. Now if we see 168 by 2, it will be 84, again 42, and again it will be 21, and it will be like this. Now 168 can be written as the pairs of only 2, and none of the numbers are in pair in the last 3 digits, that is 2, 3 and 7. So to make the number 168 a perfect square number, we have to multiply this number by 2, 3 and 7. Therefore the number 168 must be multiplied with 2 times 3 times 7 equal to 21, 42. So our required number multiplied should be 42, which completes question number B also. Now move on to question number C. At least how many troops should have to join to arrange troops to obtained in a square form? That means this time we don't have to multiply, we have to add. So when we add any number, we need to find the square in a way that 168 here, 168. So if we make it perfect square number, we want to make it perfect square number. At first we have to check whether it is a perfect square number or not. So be 44 and here will be 24. So clearly 168 the nearest, therefore the next perfect square number, square number will be 12 plus 1 whole square, that means 13 square, which is 169. Therefore the number of troops should have to join. We have to subtract this original number 168 from our new number 169. So we will get 1, which is our required number. I hope you understand. Now I want to give a homework which is related to the word problems number 21 and 22 of this chapter. Now I just want to give you the question and a clue. Extra creative question related to question 21 and 22. So you copy the question at first and then try to solve it. So question. I'll give in your written form the difference of squares of two consecutive numbers is 37. Question number A. If the smaller number is x, then form an equation. Of the situation. You have to make an equation of this situation, the difference of squares of two consecutive numbers, where one number is x, so next number, smaller number is x, so next number will be x plus 1. Question number B, find the two numbers, find the two consecutive numbers and question number C, find two such least consecutive numbers so that the difference of squares their squares is also a perfect square, which is your homework. If you follow the questions 21 and 22 of this chapter, you can easily solve this problem. So you try at home, practice. I hope and I believe you can solve this. Now another one will be your homework, HW extra CQ, this extra CQ, and also example number 11 of this chapter, example number 11, page number 15. So these two will be your homework, and also the three problems I have solved, number 10, number 23 and number 24 will also be your homework, which completes our topic in arithmetic. Hopefully next class we will start another topic. Till then, goodbye.